Hello dear students, welcome back to my YouTube channel Anveshana Academy. This is Dr. Manjunath Chennapgood. Dear students, in the previous class we were discussing thermal resistance. Up to here we have discussed when the two materials are contacted. Okay, so when we are seeing it in microscopic level, there is a small gap we are going to get in between these two materials when they are joined perfectly. So due to cause of that small gap between two materials, there is a drop in temperature. Because of the drop in temperature, there is a resistance to the flow of heat that we have discussed in detail in the previous class. Come dear students, we will continue that concept. Okay, now I told dear students, here it is a temperature T1. Okay, so the material 1, this side I will mark as a T1, so I will write it here now, that is T1. Then it reaches material end of the material A1 itself. That temperature here, the temperature is it is going to drop at this particular point. The temperature where it is going to start to drop, right, that temperature I will mark here now, temperature TC1, thermal contact temperature at 1. Then it is going to drop somewhere else because of the air gap or void. You can, because of this air void or air gap, there is a drop in temperature. That drop in temperature up to that point I will mark here as a TC2, the temperature drop due to thermal contact resistance, that I will take it here TC2. Then heat is going to transfer from this point to this point in a homogeneous material of B. Hence it is having same thermal conductivity. Hence the temperature drop in that material B is linear. So that means what, T2 is what, linear, where D1 represents initial temperature and T2 represents final temperature of the composite material, whereas TC1 and TC2 are the intermediate temperature of what, thermal contact. Okay, this is what temperature variation with respect to thickness of the plate or length of the plate. Dear students, when it comes to this particular point, right, this is material A, it is having same thermal conductivity, that is Ka I can mark. This is material B, I can take, it is having thermal conductivity of B. Because of thermal conductivity we can get linear decrease in the temperature. But when it comes to here, there is a drop in temperature because of the air gap, dear students. The same thing what I can do, I can express in terms of the same concept I can express in terms of thermal circuit. What is that thermal circuit that you can see here, dear students? It is a material A, right? In that material A, there is a thermal resistance. I will mark here as a R1. So what is that now? You can see now, when the heat is flowing from this end to this end, right? Then there is a, when heat is flowing in a material, there is a small resistance will be there in the material. That resistance I will mark here as a R1. When I contact these two materials, right? So I can mark here now resistance 1. Then there is some more resistance that I can call due to contact of these two material. We are going to get a small gap. Because of that small gap, there is a resistance to the flow of heat. That resistance I will mark here as a resistance due to contact of the material. So I will mark here as a RC, resistance due to contact. So that I will mark here now RC, dear students. Then next, heat is going to transfer from this intermediate point to this point. That means what, again temperature is going to decrease, that too in linear. That temperature is there, okay, fine. But the heat, when it is moving from this point to this point, there is some resistance. That resistance I will mark here as a R2. So I will mark that resistance here as a R2. So whereas R1 represents what, resistance of the material 1. Then RC represents the resistance due to thermal contact, due to contact of the materials. Then R2 represents thermal resistance at material 2. So these three are in series, dear students. Now this heat is going to transfer from this end to this end due to temperature potential difference, that we can call it here as a delta T, dear students. Okay, this is what thermal resistance. Come last. Okay, this is a configuration diagram and it is a thermal circuit, we can say, dear students. Okay, fine. Now thermal resistance, in simple terms what we can say, thermal resistance is a measure of material's ability to resist the heat flow. Sometimes what will happen, dear students, when it comes to engineering application, we have to resist the flow of heat. Like you can take human body, right? When it is a human body, right, in a winter season, whatever the heat is generated from our body, right, we should stop that heat to transfer from our body to the surrounding, right? So because winter season, the temperature may be 15 degrees Celsius or 20 degrees Celsius, but we can feel comfort when our body is at 98 degree Fahrenheit or 37 degrees Celsius. If it is less than that, what happens? Our body is going to feel uncomfort. At that moment, what we are going to do to maintain the optimum temperature of our body, that is 37 degrees Celsius, what we are doing? We are using some insulating materials or sweaters or some thick materials we are going to wear in the winter season, jacket and all those things, right? We are wearing, right? So to resist the heat flow. So that is nothing but application of thermal resistance. I am going to discuss in detail that later. Okay, the materials means what? How much that the thermal resistance is nothing but what? It's a measure of material's ability to resist the heat flow, and it's the inverse thermal conductor, and it is the inverse of thermal conductivity. But thermal conductivity is the ability of material to conduct the heat, but thermal resistance is what? It's a measure of ability of material to resist the flow of heat. That is known to be thermal resistance. Okay, fine. A higher thermal resistance indicates a lower rate of heat transfer through a material. That means what? Dear students, if the heat is transferring in a material, if there is a lot of resistance to the flow of heat, that means what? We can say that there is a less rate of heat transfer. That there is a less rate of heat transfer. Dear students, to understand that, I will take an electrical wire. You can take a copper or aluminum wire. I am going to supply electricity at here. That is current. There is a voltage 1 and voltage 2. Voltage difference will be there, potential difference. See, the current is moving in this direction. Then if it is moving, definitely there is a resistance in the flow of electricity in the wire. That resistance we can mark here as a REL. The potential difference, that is voltage V1 and V2. The moment of current I will mark here as a actually. So then what I can do now? R is equal to resistance V to the I actually. Ohm's law. Similarly, when it comes to a metal plate, you can take, I am going to supply certain amount of heat at one end, that is potential difference. We can say take here out T1 minus T2. The temperature at high end, I will take it here T1. Temperature at low surface, I will take it as a T2. Heat is going to move, heat is going to transfer from 1 to 2. Across a material, that material is having a thermal conductivity, that material is going to have a thickness, that is T. Okay, if it's so, dear students, as the current having some resistance to the flow of current, right? Here also the heat also having some resistance in the moment of the heat flow in the material. So that I can mark here now. So T1 initial temperature T1, final temperature T2 I can mark here now. Whatever the resistance is going to offer in the material, right, that I can call it as a R or thermal resistance also we can call. Okay, so that is what. So T1 and T2, some authors they will write T1, T2, R they will mention, and equation for that R is equal to delta T by Q. Okay, fine. Now this is what thermal resistance. To calculate the thermal resistance, that means what? I am telling, right, there is a thermal resistance in the material by giving some amount of heat, and I may give that to temperature. The heat is moving. Then how to calculate the amount of resistance? That I can calculate with help of an equation. That equation R is equal to L divided by Ka. What is R here now? Thermal resistance. That is in what? Kelvin watt or degree Celsius watt. That is nothing but delta T is the change in temperature. That I will tell. Okay. That is the thermal R is equal to thermal resistance. That is in Kelvin or Kelvin per watt or degree Celsius per watt. Then L is nothing but what? Thickness of the material, that will be in meter. Then K is what? Thermal conductivity of the material, that is watt per meter Kelvin or watt per meter degree Celsius. Then A is what? Cross-sectional area of the material. Then this resistance I can express in another simple term also. What is that? R is equal to delta T divided by Q. What is delta T here, dear students? You can take whenever the heat is flowing from T1 to T2, right? That T1 minus T2 is nothing but change in temperature. That is what delta T. Then Q is nothing but what? Amount of heat transfer per unit time. That I can take it here now. So this is what? Thermal resistance calculation. How to calculate thermal resistance. Okay. Then is there any application of thermal resistance? Yes, there are n number of application we can find in our day-to-day life, dear students. Okay, see here now, building insulation. So in building insulation during summer season, what will happen now? Sun radiations will be more. To avoid that sun radiations or sun energy or heat energy, it is going to enter into home, right? To avoid that heat energy or radiations, what we are going to do? We are going to put a insulation. That man is going to put a insulation on your roof of the top. Okay, then what happens? That means the sun energy or solar energy or heat energy will not enter into your home. That is it will not enter because of the insulation. Insulation means what? Insulation is a material, it will not allow to transfer heat into the home. That means what? It is going to prevent the heat transfer from system to the surrounding or surrounding to the system. Hence, building insulation is also one of the best example for what? Thermal resistance. And electronics cooling. Sometimes cooling electronics items, what we are going to do? We are going to do some spray coating. Why so? To avoid the heat transfer from system to the surrounding or surrounding to the system. That's also application we can take. And best example is clothing, dear students. You can take a man is going to wear a very thin shirt or cotton shirts in summer season. Why so? Because his body is going to liberate more amount of heat. Okay, the body temperature, it will be around 37 degrees Celsius, but sometimes what happens in summer season, the temperature is going to reach 40 degrees Celsius or 41 or 42 or 44 degrees Celsius. If it's so, that means what? There is a excess heat is going to generate from a body. For that purpose, what he will do? He will wear the cotton shirt or thin shirt and he will move somewhere else where air is there, or else he may sit under the tree actually. Right? So he want to transfer more amount of heat or excess amount of heat to what he is having to the surrounding. Hence he is wearing the cotton shirt. Right? So because that cotton shirt is in a not what it will do, it is going to transfer more amount of heat from his body to the surrounding. Hence what we can say, it is not one thing, but okay, dear students, 1 minute. Okay, that is in summer season, but when it comes to winter season, what happens? Your body will be your body will feel comfort when it is 37 degrees Celsius. When it comes to winter season, right, the body atmospheric temperature may be 20 degrees Celsius. Your body want to maintain 37 degrees Celsius. That means what? Outside is cold. For that purpose, what you will do? You are going to maintain the temperature of your body as 37 degrees Celsius by wearing the jacket, okay, scarf and hand gloves. Right? So you are going to avoid the transfer of heat from your body to the surrounding with the help of what? Some jackets or scarf or some caps or hand gloves. That means what? These here hand gloves or jacket or scarf act as a thermal resistors. Their thermal resistors means what? They will prevent the transfer of heat from your body to the surrounding. Hence clothing play a very important role in our day-to-day life, dear students. Sometimes what will happen when it comes to summer, we are going to wear thin shirt, right, so to transfer heat from our body to the surrounding. But when it comes to winter season, what we are going to do? By wearing thick jacket or thick shirt or scarf or gloves, what we are going to do? We are going to resist the flow of heat from our body to the surrounding. Hence what? This all clothing also best example for one thermal resistance, dear students. Like that engine also. In engine also we are using some thermal resistors to avoid the transfer of heat from engine to the surrounding. Okay, fine. Now in one more example you can see here now, dear students, in your home. Okay, wall insulation. Dear students, what we will do? We are going to paint the wall. So wall we are going to prevent. So summer season what happens? The sun energy is going to enter into your body, into your home, right? To avoid that, we are going to put some reflective coatings. That reflecting coatings, they will act as an insulation. What they will do? They will not allow sun energy to enter into your home. Hence what they are doing? They are resisting the flow of heat into your home. That means what? That wall insulation or wall painting with the reflective coating is nothing but what? Insulation, we can say, dear students. Okay, that we can say that is the best example for thermal resistance, and it will give the winter benefits. Okay, and one thing, if it is insulated well, if outside temperature is 20 degrees Celsius, then what we can do? If the insulation is there, right, it will not allow to transfer heat from your home to surrounding also. It will not transfer heat from your home to surrounding also. They act as a thermal insulation resistor, dear students. Some more it is going to give summer. If the more heat is there, heat is transferring from surrounding system or surrounding to the home, it will not do. If the insulation is perfect, then what happens? It will not transfer heat from your home to surrounding in the winter season also. Hence it is going to give winter and summer benefits also. To do that, what we are doing now? We are using some fiber glasses. The fiber glasses, what they will do? They will act as a best thermal insulation. And some we are using some mineral wool also. Then foam insulation, you can see in any buildings, at the top you can see they are going to put up foam insulation, right? So to avoid the heat transfer from inside to the outside, or from system to the surrounding, or surrounding to the system. Okay, so now these are what examples like that. You can see here now wall insulation is done, clothing, window insulation is done. Window insulation also we are going to do, dear students. Okay, why? So window insulation, how we are doing? Assume that there is a winter season, or else you can take a very cold region you can take. That means what heat is, that means what outside temperature is very less, but inside we need to maintain optimum temperature 35 to 37 degrees Celsius. Then what happens? Now heat is going to transfer from your home to the surrounding. To avoid that heat, what we are going to do? We are going to do insulation to your window also. There is a single pane window is also there, double pane window is also there. What we are going to do now? We are going to, in single pane, we are going to do some insulation. That insulation, what it will do? It will not transfer heat from your home to the surrounding. Hence what we can do? You can feel comfortable temperature in your home itself. If you want to avoid more amount of heat transfer, if you want to avoid more amount of heat transfer, that you can go with what? Double insulation or double pane windows. Then we can do some coatings also to your home, dear students, to prevent the transfer of heat from your home to the surrounding. Okay, like that. Yeah, when it is a human body, right? Human body, to avoid the heat transfer, what we will do in winter season? We are going to wear the jacket, gloves and scarf, right? Okay, then this, when whatever the material we are having, right, that material also play a very important role in the thermal resistance. What type of material we are having, that material also play a very important role in the thermal resistance. Okay, one thing. And thickness, if the thickness of the material, or you can take a jacket, what type of jacket, what is the material of that jacket, also play a very important role in the resistance to the flow of heat, one thing. And thickness, what thickness it is having. If it is more thickness, then heat flow from your body to the surrounding is less actually. That thickness also play an important. Style, then how we are going to fit that jacket to you, that's also play a very important role in the transfer of heat from your body to the surrounding. These are what? Application of thermal resistance, dear students. I hope you understood today's class. If you really understood, please do like, subscribe and comment and support. Thank you.